Hello, Honor Stats. Continuing with Chapter 2. This is going to be a section 2.2 dealing with bar graphs, circle graphs, and time series graphs. All right, continuing with 2.2. All right, ladies and gentlemen, that is section 2.2. Our focus points. We're going to determine types of graphs appropriate for specific data. We're going to construct bar graphs, Pareto charts, circle graphs, and we're just going to talk about the time series graph. We're not going to construct them. We'll just kind of explain what they do. And then we'll obviously interpret information displayed in the graphs. So first, before we get started, bar graphs. They're a little different from histograms. Histograms, the buildings, the frequency buildings are touching each other. There's no gap in between them. Why? Because you have quantitative data here and you have quantitative data here. So meaning numbers. Remember, you have the frequencies on the y-axis and you have the class boundaries on the x-axis. For a bar graph, the x-axis are going to be qualitative. They're going to be words like the number of freshmen, sophomore, juniors, and seniors that eat lunch in the cafeteria. So these are the freshmen, so you label it freshmen. But you can't be a freshman and a sophomore at the same time, so here's the sophomores. So you label with sophomores. And then the juniors, and finally the seniors, okay? So that's the difference between a histogram and a bar graph. Okay, these ones are still going to be quantitative over here in the y-axis. Okay, they're going to be numbers for the bar graph, but the big thing is qualitative for the x-axis. So we learned what a bar graph is. A special bar graph is called a Pareto chart. It goes from bigger to smaller. We learned a circle graph where we have to take the values, turn them into percentages, and take the percentage of 360 degrees. And we talked a little bit about a time series graph. We're not going to construct them. It's just kind of look at and be able to pull some information out. So that's what they're basically saying right here. Histograms, visual display using a distribution of data. However, that data must be quantitative. Bar graph, the graphs can be used to display quantitative and qualitative, which I just explained. All right, we talked about they can be vertical or horizontal. I usually do vertical. There's a uniform width and a uniformly spaced. So you want the same distance in between the bars. The lengths of the bars represents the value being displayed. And the graph is well annotated, meaning you label everything. So here's an example of two different bar graphs. They're kind of comparison, okay? Please understand that even though these are numbers, they're years, so they're separate, okay? And all it is comparing men and women and their life expectancy. You know, how long they lived being born in the 1980s all the way up to 2010, okay? But notice that there is a space in between. Look at the yellow space in between, yellow space in between, yellow. Those are all going to be consistent. That's called a cluster bar graph because there's two together. Now, a Pareto chart. A Pareto chart is a bar graph in which the bar heights represent frequency of an event. In addition, and here's the big thing, the bars are arranged left to right in decreasing height. So basically a Pareto, you will have your largest building first, then your second largest bar, then your third largest, your fourth, and your fifth, etc. So it goes down, starts with the biggest, ends with the smallest. That is a Pareto chart. And finally, a circle graph or a pie chart. Remember, we're going to talk about time series, but not in extent. This is a time series, basically. Week 1, I walked 1.5 miles. Week 2, 1. So at the end, when I'm getting in better shape, in week 20, I walked 2.7 miles. So basically, a time series is a timed event. So in this case, it's days, and how you increased or decreased something. We're not going to construct or do anything. Okay. We want to get to a pie. Okay, so let me open this up a little bit. So if we're looking at this, the frequency of cell phone use in public to catch up with family and friends. Notice they gave us the frequency of each of them. So 894, they use their phone frequently. 1161 occasionally. 615 rarely. 372 never. We're going to find the relative frequency. So we're adding these numbers together and we get 3042. And then we divide each frequency by 3042. It's going to yield a percent. These are all the percentages. Then a circle. A circle consists of 360 degrees. So we're going to take that percent of 360 and we're going to get a degree measure. In this case, 106. That's your frequently using cell phone. We're going to take 38%, 38.2% of 360 and we get 138. 20.2% of 360 and get 73. And 12.2% of 360 and getting 43. So my degrees are 138 degrees. I'm going with the largest. 106 degrees, 73 degrees, and 43 degrees. Now let's put it into a pie chart. So you draw your circle. Notice occasionally is the largest one. So therefore, I'm going to draw this line here. Let me do it in red over top of this so you guys can see how I do it. So I draw this line here. And I say to myself, if I rotate, I need to rotate 138 degrees. So knowing right here is 90 degrees, so I have a bit more to go than that. I do undo that. And therefore, I come to here. So this, ladies and gentlemen, is 138 degrees. But we don't want that. You're not supposed to put the degree measure. You write what the value is, or what the word is occasionally, and you write the number 1161, excuse me. Okay. Let me see if I can back up. Okay, now from here, we're going to do the next value, which is 106 degrees. So we're going to rotate from here 106 degrees, and that's our frequently, and label it with the 894. From there, we're going to rotate 73 degrees, so this is 73 degrees, and you get the rarely, which is the 615. And finally, what's left over is the 43 degrees, which is the never, and the 372. So when you saw this at the beginning of the video, the red was not written on there. So you have to be able to look at this without the red, okay? Just the blue, okay? So let me get rid of all this red, which was the degree measures. And when you're done, this is what we want. Just what you see in blue, okay? There is no degree measures written anywhere. No degree measures written anywhere. But the values, the frequencies, and we're done, okay? So, just an overview of this particular